Give me your number, I call you up. You act like you're gonna interrupt. I don't have no trouble with you fucking me, but I have a little problem with you not fucking me. Baby, you know I'm
Okay, now for question number 3. It says to solve each equation for the variable. So this has a part A and part B. We're just going to work on part A for now. So we have this equation here, which is 4 raised to the 4x minus 7 power is equal to 3 raised to the 9x minus 6 power. So it's like, okay, what? What is going on? So the thing is that we have to solve for x, right? But we need to get it out of the exponent. So in order to do that, we have to somehow implement the inverse of an exponential function. So that means we're going to use logs in some way, right? So some kind of logarithm. So in this case, where we shouldn't use you can use like log base 4 or log base 3 in order to get rid of an entire side completely. But the thing is here, when the bases don't match, like our 4 and 3, what we can do is just use the natural log, right? So natural log meaning ln, or log base e. So if we ln both sides, so let me write out what we have here, is equal to 3 times to the 9x minus 6. So if we ln both sides, okay, so we're just going to write ln on both sides to keep that equality there. Then what we can do is just take each of these exponents, use the exponential property of logs, and move it down in front on each of the sides, okay? So now we get 4x minus 7 times ln of 4. And we see that ln of 4, just like ln of 3 on this side, ln of 3. So ln of 4 and ln of 3 are both just constants, right? Because that just means you're taking log base e of 4, and if you were to plug that into your calculator, you just get one value, okay? So these are both constants, so we can treat them as constants as well. Okay, so what we're going to do is just distribute those in here, distribute it on this side as well, and we're just going to solve for x using normal algebra. So we get 4 times ln of 4 times x minus 7 ln of 4. Okay, and this is equal to 9 times ln of 3 times x minus 6 times ln of 3. Okay, and now we're just going to move all the x's to one side. So let's say we move it, I don't know, to the left side. So we have 4 times ln of 4 times x minus, I'm going to subtract this over to the left side, so minus this 9 ln of 3 times x is equal to, and I'll add this guy over to the right side at the same time. So this is going to be a 7 ln of 4, and then minus 6 ln of 3. So we see on the left side we have an x in both of these terms, so what we can do is just factor that out. So we have x all the way at the end, and we're just going to combine the coefficients of x, so minus 9 ln of 3 is equal to 7 ln 4 minus 6 ln 3. So then just to get x by itself, we're going to divide by this whole thing in parentheses, and let's do that on the next slide to finish up. So we have 4 ln 4 minus 9 ln 3, and then times our x, is equal to a 7 ln 4 minus 6 ln 3. Okay, so we're just going to divide by this parentheses thing on both sides. Minus 9 ln 3 divided by 4 ln 4 minus 9 ln 3. And we can do that because it's a constant, right? So those ones go away on the left, and we get that x is finally equal to 7 ln 4 minus 6 ln 3 divided by 4 ln 4 minus 9 ln 3. Okay? So that's your answer without a calculator, and if you do have a calculator, you'll find this is about negative 0.7168. Okay, now for part B, we're going to solve this equation. We're seeing that we start with log, so we'll have to do some kind of the inverse in order to get rid of that log, so we're going to have to exponentiate at some point. Okay, but for now, let's actually consolidate these two logs into one. Okay, so because they are connected with a plus sign, that means we have a product going on, right? So log of x times x plus 3 on the inside is equal to 3. Okay, and then we can just combine stuff on the inside in order to make this a log of x squared plus 3x, right? And then is equal to 3. Okay, and now we see, okay, how do we get rid of this log? So this is the point where we're going to have to use an exponential of some sort. So we see that this log is the common log with base 10, right? So we can just exponentiate using a base of 10 on both sides in order to cancel that out on the left. So now we have x squared plus a 3x is equal to 1,000, right? Because that's 10 to the third. Okay, if we subtract from both sides that 1,000, we just get x squared plus 3x minus 1,000 is equal to 0. And this I do not believe is factorable, or easily factorable. So what we're going to have to do is just plug it into the quadratic formula. So let's do that up here. So we have x is equal to negative b, so that's negative 3, plus or minus the square root of b squared, so 9, minus 4 times a, 1, times c, negative 1,000. Okay, all over 2a, so that's 2 times 1. Alrighty, so this can be a little bit simplified. So this is negative 3 plus or minus the square root of 4,009, and then all over 2 there. Okay, and when you plug this into your calculator, we actually get two answers, right? So two solutions to this equation, to this quadratic. So 30.158 or negative 33.158. So this is a little bit weird. So it's like, okay, wait, which solution is it? And the thing is, we have to go back to our original equation up here, okay, and see, okay, which one works and which one doesn't. And let's see if both of them work or both of them don't. So for the first one, well, actually, let's look at this negative. So if we try to plug a negative in, we get log of negative 33.158. So wait, freeze. Log of a negative number? That's not possible, right? So we can't have a log of a negative number, so it cannot be this, this negative number here is not a solution to our equation, okay? So we're finally going to get that x is equal to 30.158. Alright, so that concludes our practice problems video on the section on logarithmic properties. I hope that helps, and good luck on your homework.
Baby, I got your money.